Hello Trig class. We're going to go over lesson 13.4 today, which is about graphs of the sine and cosine curve. So we're going to address certain key points on how to graph those and how to go about finding those key points both graphically and within the equation when we're using sine and cosine. So we'll get right into it. Hopefully you've got your guided notes, and you should also have this graph of the sine and cosine curve handy as well, as we'll take a look at that periodically as we go here. So first off, we'll talk about the graph of sine. The graph of y equals sine of x, so some value x, is shown on your handout. So as you can see here on the handout, sine is the one in yellow. Yours is black and white, I believe, but you can tell the difference on yours. I believe the yellow, the sine curve, is quite a bit lighter than the blue cosine curve. So this yellow sine curve, or it will be the lighter one on yours. That's shown on your handout. You'll notice as you're looking at that, the graph repeats itself every 2 pi units, or as we know, 2 pi is 360 degrees. So you'll notice that this graph repeats itself. Let's say it started right here, that's at negative 2 pi, up, down to a minimum, back up to where it started, and then you'll notice that it does the same thing all over again. Okay? So it repeats itself every 2 pi units, and as we learned last time, that would indicate that the period of this sine curve is in fact 2 pi, because we know the period is equal to when it repeats itself. And you'll also notice that it is symmetric with respect to what? If you take a look at it real quick, this is not symmetric with respect to the y-axis, is it? If I folded it, this yellow graph would not be on top of itself. However, if I folded it on the y and then the x-axis, it would in fact be on top of itself. And that indicates that it is symmetric with respect to the origin, correct? Origin. As you should know, if it is symmetric with respect to the origin, it is an odd function. You'll notice it has a maximum height of 1 and a minimum height of -1. This is going to be our most basic equation of the sine curve. Kind of like y equals x is the most basic line. Y equals x squared is the most basic quadratic. Everything builds off of that. It's going to be the same thing for the sine. Okay. Now, when we go look at the graph of the cosine, so the graph of y equals the cosine of some value x, that's also shown on your handout. It is the darker line, I believe. I hope I'm not incorrect in that. Yeah, I'm right. You'll notice the graph repeats itself again every 2 pi units along the x-axis. That indicates that the cosine also has a period equal to 2 pi. However, this one, let's take a look together. This one is symmetric about the y-axis. It's pretty obvious that if I folded it at the y-axis, it would be on top of itself, right? So that is symmetric with respect to the y-axis. And I didn't put that in here for some reason. I didn't, but that would indicate that it is an even function, right? So that would indicate It's an even function. Not sure why I don't have that in the notes here. It also has a maximum of 1 and a minimum of -1. So what you'll notice is these graphs are very similar, as you can tell. They look to be the same, only one is shifted, isn't it? If we were to shift this to the left, we were to shift this point right here and have the whole curve of sine to follow it. If we were to shift this way, this direction, so I moved it pi over 2 units, it would be a mirror image, right? Or an exact same image as cosine. So that's important. Notice if that were shifted pi over 2 units, either one to the right or the left, it would coincide with that sine curve. Coincide. Alright, so that's the most basic of sine and cosine. And what we're going to go on into today is how we're going to alter that. Kind of like how we add different slopes and different y-intercepts to a line to shift it. That's what we're going to do right now, only it's not a slope, but we will in fact shift it up and down. We'll stretch it vertically and stretch it horizontally, and we'll show you how to go about doing that. First thing we're going to talk about in that aspect of things is the vertical shift. So the graph of a function in this form, so you see I've already altered this. I've added a c to either sine or cosine, right? That can be obtained from that graph, okay, of sine of x, or y equals cosine of x in this case. So we can get these from altering these. And we do that by shifting the graph up, whatever value c is, if c is positive, or down, whatever value c is, if c is negative or less than 0. So that makes sense, right? Think about this for just a second and take a look at this equation. If I have y equals sine of x, and I add something to the sine of x, instead of being where I was here, aren't I just changing that y value? Aren't I just adding c to it? So that would make sense that I take whatever graph I had with this one and I move it up c units. Or over here, or excuse me, if c was negative, I would take whatever graph I have right here and I would move it down c units, because I'm reducing all of my y values. Okay. Now these start inspire activities, we are going to work on those in class when you come back on Monday and Tuesday. So if you've got an inspire and you would like to go ahead and graph these and see what it does, feel free, go right ahead. I'd encourage you to do that, but we will do that activity in class. Okay. The next thing we're going to talk about is amplitude. And for a function in this form, see, now instead of just adding something, I am taking the sine or the cosine of x and I am multiplying by some constant. If a is greater than 0, that number a is called the amplitude. Okay, the amplitude. It's going to have a minimum. Alright, it will have a minimum equal, or a maximum, I'm sorry, equal to whatever the value of a is, and it will have a minimum of whatever the value of negative a is. So we know that our basic functions, sine and cosine, had a maximum of 1 and a minimum of -1. Well, if we go and multiply that value by some number, What that does is that makes my new maximum y value, whatever that number is, and my new minimum y value the opposite of whatever that number is. Okay? That constant a causes what we call a vertical stretch or shrink of the sine or cosine curve. So you can imagine what it will do if you take a look at this. It will essentially, you have the same graph here, only now you're going to make it taller. You're going to drag cosine up. Let's say I had a 2 in front of that, and that would send that maximum up here. It would send the minimum down here. Okay? So just try and visualize that. Again, if you would like to, and if you have access, go ahead and graph it on an Inspire if you have one handy. Okay. The last thing we're going to talk about is the period of sine and cosine, because that can be altered as well by changing another part of the equation. So the period of a function in the form y equals sine of, now instead of just x, I am taking x and I am multiplying it by some coefficient. Okay? The difference is up here my coefficient was out in front. The number I was multiplying it by the sine. In here I'm taking my coefficient and I am multiplying by whatever value x is, right? So the period of that function, when it's in this form and b is greater than 0, the period of that is going to be found by this equation right here, 2 pi over whatever that coefficient of x is. So that constant b causes what's called a horizontal stretch or shrink. So as we look of that sine or cosine curve, so as we look again at this, what's going to happen is instead of this being 2 pi, we're going to shrink this whole graph. So imagine this whole thing shrinking as I'm dragging this outside in, everything else is shrinking up tighter as well. You know, let's say I change the period to pi. Well, this would have to go up here, down here, and then back up and be done here. Whereas now it's done at 2 pi, it would then be done just at pi. Oops. Okay, and again, you can graph that if you have access to an Inspire right now. Now the maximum and minimum values, we told you that those are found, we can find the amplitude here. If we just have something being multiplied by the sine or cosine, that amplitude will give us the maximum or the minimum. But there's a chance that we could have more than one of these things going on. If we have a vertical shift and a change in amplitude, then we're going to have a change in the maximum and the minimum. And that's where, that's where we will get, or where we will need to use all of this information here. So we'll just use a capital M for maximum, a lowercase m for minimum of a function, and we're going to talk about in the form of having all of these components happening. So C meaning I've got some vertical shift, A meaning I've got some change in amplitude times the sine of B times x, meaning I would have a change in period. Now the change in period won't necessarily change the minimum and maximum. So we'll either have that for sine, or everything's the same except for we're talking about sine and cosine both, right? Where A is greater than 0. And the maximum and minimum, if we have a C and an A involved, will be given by the following. The maximum will simply be whatever that vertical shift was plus whatever that change in amplitude was. Okay. The minimum will be whatever that vertical shift was, because what that does is that vertical shift will move the center of the graph up or down. So to get the minimum, I'll subtract that amplitude. So look real quick at this graph. What a vertical shift will do is take the whole graph and move it up. Okay, so what it does is it changes the center. Okay, the C value is always going to be the middle of your graph. Okay, so if C is 1, then you're going to take all this up, and now the middle of these graphs are going to be at 1. If C was -3, you would take these graphs and you would move them down 3 units, so the middle would be at -3. Okay. These values can also be used to find the vertical shift in amplitude, so you can go both forward or backward in this case. So let's say I had a graph and I knew the maximum and minimum, or I wanted to know C. Okay, so let's say I had a graph and I wanted to write the equation. Well, if I have a graph, I can look at the maximum, I can look at the minimum, and then you divide that by 2 and you get your C value. A is found by taking the maximum minus the minimum and dividing by 2. Does it make sense? Remember that C is going to be where the middle is, and that amplitude is going to tell you how much you're going to go up and how much you're going to go down from the middle. Okay. So we will go on and look at a couple examples here. Example number 1. For the function y equals 1 plus 2 sine of pi x, find the amplitude, the maximum, the minimum, and the period. So this is essentially a test in can you use the components of this in order to find what you need to graph it. Okay, so let's look at this equation. First thing you need to do is identify C, A, and B. C is what I add to the equation. Now sometimes C will be at the beginning, like it is here. So here my C is 1. Sometimes, however, you'll see some books or some different textbooks will have that C value out here at the end. I like to have it up front because sometimes when you put it out here at the end, people have a tendency to get it mixed up or blended in with what you're taking the sine of. So when I write it, I'll have it at the beginning here. Okay. The A value, remember the A value is the coefficient or what you are multiplying by your trig function. So here the A value is 2. And remember B is your coefficient of your x or what you are taking the sine of. So here B is pi. And remember pi is not a variable, it's a number. Okay? It's a number. Alright, so it says find the amplitude first. Amplitude. Well, if you remember, amplitude is simply equal to our A value. So that's pretty easy. Amplitude is 2. We can find our maximum. Remember that our maximum, like we just said, is C plus A. So we've got C and we've got A, so that's 1 plus 2, which would equal 3. Remember that our minimum is C minus A, which would be 1 minus 2 to give me -1. So I'm just thinking to myself right now, the maximum of this graph, this sine graph, would be at 3. and the minimum's at -1. So it's like I stretched this up to 3, and this stayed here, but my middle changed, right? Because my amplitude was 2. Okay? So by my amplitude being 2, that means my middle will have changed to 1, okay, and it will go up 2 to 3 and down 2 to -1. And this will be a little easier to see when we start to graph them on our inspires. Okay, now in addition to those, it wanted us to find period. So our period is equal to, if you remember from the previous slide, or actually 2 slides ago, is found by taking 2 pi and dividing by b. Well, in this case, that would be 2 pi, and our b was equal to pi, right? So those simplify to 2. Alright. So now I've got all the components to be able to graph it, and that's what we're going to do in step 2 here. It wants us to graph the function given in example 1 and show 2 periods. So the period is 2. It wants us to show 2 periods. I'm going to take you through the process that I feel like is the easiest. The first thing I want to do is realize that C means I have a vertical shift of 1 of the regular sine curve. So the regular sine curve, the middle is the x-axis, right? So if I have a vertical shift of 1, that means all of these middle points, if you take a look here, see the sine curve? This sine curve crosses at the beginning, the middle, and the end of these. Okay, so those are 3 key points: the beginning, the middle, and the end. Those are the key points we want to be able to graph, and they are at the right here at the beginning, like we said. It crosses that middle point halfway through the graph and at the end. So by changing my middle to be up here at 1, that means I'm going to have a point right here, and halfway through, well, halfway through, if my period is 2, I'm going to end over here, right? Well, that sine curve is also going to cross in the middle, and it said it wanted me to show 2 periods, so I am going to carry those over here as well. Here will be the end, and here will be the middle of the left period, if you will. Now my other key points are the maximum and the minimum. The maximum is at 3, and if we look at the general sine curve, we start and we go up to the maximum, right? And the maximum will be halfway between where you started and the middle of the graph, or 1/4 of the way through the period. Well, 1/4 of the way through one period, if the period is 2, 1/4 of the way would be right here, right? So that's where your maximum goes. Then your minimum goes 1/4 of the way between the middle and the end. Your minimum was at -1. So I've got those over here as well. If I was starting here, it would go to my maximum up here in between those, my minimum down here. Okay. So I graphed both periods at the same time. I could have just graphed one, and let's go ahead and let's see here. Let's draw this. I'm going to make this dotted, and make it go like this. So I try to draw a smooth curve, as smooth as I can with this technology. A smooth curve, and that would be 1 period, right? 1 period would take me through there. one period. Doesn't have to be, you don't have to be Picasso, right, to draw these. You just have to take your time and do your best, okay? That is a graphing this with two periods. So I would probably start by graphing this one period, and then I can continue it over here to the left. It would make sense that if the period was equal to 2, that to draw two periods should span 4 units, right? And to go from -2 to 2 is in fact 4 units. Okay, so that is the graph of y equals 1 plus 2 sine pi x. Now, the key things to look for, you always want to check your work. Remember, this 1 is real easy. It shifts everything up 1. Well, you can tell pretty easily, right? I shifted the middle of this graph up by 1. That looks great. The amplitude is 2, and the amplitude tells me how far I go up from the middle and down from the middle. And I go, if the middle's here, I went up 2 to the maximum, I went down 2 to the minimum. Okay. So hopefully you get the general idea there. Okay. We're going to go on. That's the only graphing example we're going to do, and we'll work on some more of this in class, especially when we get the calculators out. Start viewing that. Let's look at example number 3. Find an equation in the form y equals c plus a times sine of bx. So that's got it all, right? That's got a vertical shift. That's got a amplitude or a horizontal or a vertical stretching, and it's got a b value, so it's got a horizontal stretching or shrinking as well. It satisfies the following conditions. So they give me the maximum, they give me the minimum, and they give me the period. Well, I know in order to write this equation, I need to know 3 things. Whoops. Guess I can go back to writing regular here. Don't need arrows, do I? I need to know C, I need to know A, and I need to know B. So I always like to think of what do I need in order to answer this problem, and then I'll go back and I'll figure them out individually. Well, if I need C, I know that from slide number 3 on the presentation, I've got some, if I have a graph or if I have certain information, I can find C. Well, C is equal to the maximum plus the minimum divided by 2. I'm just going to plug in 4 plus -2, which is the same as 4 minus 2, right? Over 2. So 4 minus 2 over 2. It's 2 over 2, which I know is 1. So I've found C. Boom. Done. A is equal to m minus maximum minus minimum divided by 2. Well, that's 4 minus a -2, so you got to be real careful here when you're substituting in. Remember, put them in parentheses. Take your time. 4 minus a -2 be 4 plus 2, which is 6 over 2, which equals 3. So my A is 3. And now to find B. Okay, this is the part that always confuses people. People get hung up. They never remember how to find B. They think that B is the period. Remember, B is not equal to the period. It is absolutely not equal to the period. B is a component of the formula for period, or the equation that gives you period. Remember, your period of one of these curves, or these graphs, is equal to 2 pi over B. Well, I know what the period is, right? And I know what 2 pi is worth. The only thing I won't know here then is b. So when I substitute in, I'm going to change colors here. I get 4 pi is equal to 2 pi over b. Alright? So I need to solve for b. People get mixed up here too. It's basic algebra, but sometimes this is our hang-up. Don't let this be our hang-up. If I want to solve for b here, I can't keep b in the denominator. So I've got to get it into the numerator. And how am I going to do that? I'm going to multiply both sides by b. Then it's gone over here, right? And now I've got b times 4 pi, and that's equal to 2 pi. Well, now all I have to do to solve for b, if I'm multiplying by something, what do I do to get rid of it? I divide both sides by 4 pi. I'll change colors again. 4 pi is gone, right? And pi is gone, and the 2 will turn into a 1, the 4 into a 2. So b is equal to 1/2. This right here is what people mess up. Okay? I'm telling you that right now. B proves difficult for people. And just for my final notes, I'm going to make that blue. I don't know. Just because that's how I am. Sorry about that. So, our final equation then. Don't forget to do the equation. You did all that work. C, which is 1 plus a times sine, so 3 times the sine of b times x, so it'd just be 1/2 x. Or sometimes you might see that as x over 2. That would be fine as well. Okay. Alright, so we're going to do those that TI Inspire activity. When you guys get into class, we're going to look at these vertical shifts and horizontal shifts and things of that nature, and see what all these changes do to these graphs. We can see them in real time, and hopefully that'll give you an idea of what's happening with these. But we will, after that activity, we will work on 1 through 38 all in lesson 13.4. So we will see you on Monday or Tuesday.